Questions 21 to 25 on the 2006 AMC 8 for grade 8. An aquarium has a rectangular base that measures 100 by 40 and has a height of 50 centimeters. The aquarium is filled with water to a depth of 37 centimeters. A rock with a volume of 1,000 centimeters cubed is then placed in the aquarium and completely submerged. How many centimeters does the water level rise? So first let's draw a aquarium. So here's our aquarium, and our dimensions they tell you is 100 times 40 and 50 for the height. And then they tell you that you've got water till about 37 centimeters approximately. And then you drop a small, I guess, rock or pebble or something. Yeah, rock. And that rock, once you drop it in, it makes the water level rise a little bit. And they want you to figure out how much. Okay, so initially the volume is going to be 100 times 40 times 37, correct? But then when you add this rock, it increases that volume by 1,000. And then that is equal to the same base, 100 times 40, but you have to multiply now by a new height. And that new height is not going to be 37 because you've added 1,000 cubic centimeters of volume. So let's do this mathematics. It's 149,000, and that's equal to 4,000 H. And if you divide through, you get H is equal to 37.25. So the water level was 37, and now it's 37.25 because it went up a little bit because of that rock being inside the tank. 21, the answer is A. Three different one-digit positive integers are placed in the bottom row of cells. Numbers in adjacent cells are added, and the sum is placed in the cell above them. In the second row, continue the same process to obtain a number in the top cell. What is the difference between the largest and smallest numbers possible in the top cell? All right, a little bit of trial and error here. So let's see what happens. I want the smallest and the largest. So let's first start with the largest. Well, if I want the largest possible sum here, I'll start with the largest possible one-digit numbers down here. So I'll choose 9, 9, and 9. But I can't choose that, unfortunately, because it has to be three different. Okay, three different. So how about 9, 8, and 7? If that's the case, this will be 17, and this will be 15, and that becomes 32. Okay, so that's my largest. Now let's do the same thing, but this time do the smallest. Well, the smallest is going to be 1, 1, 1, correct? No, because they've got to be three different numbers. Okay, how about 1, 2, 3? That's about as small as I can go. So this will be 3, this will be 5, and this will be 8. So 8 is my smallest. So 32 minus 8 is 24. That's the difference between the largest and the smallest. But guess what? This is the wrong answer. So you say, well, why is that the wrong answer? I mean, I don't think you did anything wrong. This is the proper way of doing the question. Well, that's what you would think, but this question is tricky. It's tricky because our orientation is wrong. And please allow me to explain. Orientation is wrong because the 1 needs to go in the middle, right here. And similarly, when you put the big numbers, 9, 8, 7, the 9 also has to go in the middle. That's how you get the absolute smallest and the absolute largest. So this question is a little tricky, and unfortunately, that is wrong. But I wanted you to see that because a lot of students will make that mistake. So here we go. Let's start again, but this time with the proper orientation. The largest numbers are 9, 8, and 7, but the 9 goes in the middle, and then the 8 and 7 can go the other boxes. And then this becomes 16, and this is 17, and therefore this is 33. So 33 is, as you can clearly see, larger than 32. So that's the largest possible. Now let's do the same thing, but this time we're trying to get the smallest possible. And remember, orientation is important. So the 1, 2, and 3 are going to go in those 3 boxes, but in a different orientation. The 1 goes in the middle. 2 and 3 here. 2 plus 1 is 3, 1 plus 3 is 4, and this is 7. And as you can see, 7 is smaller than 8. So there you go. The largest and smallest possible are 33 and 7, and their difference is 26. And that is the correct answer to number 22, which is choice D. A box contains gold coins. If the coins are equally divided among 6 people, 4 coins are left over. If the coins are equally divided among 5 people, 3 coins are left over. If the box holds the smallest number of coins that meets these 2 conditions, how many coins are left when equally divided among 7 people? So I'll let C be the number of coins, and if you divide the number of coins by 6, you get a remainder of 4. If you divide the number of coins by 5, the question says you get a remainder of 3. Okay, so let's first concentrate on this. Let's try to get a value for C. Well, the smallest possible value for C that gives a remainder of 4 is 10, right? Because 10 divided by 6 will give a remainder of 4. But if C is 10 over here, 10 divided by 5 is an integer, and there's a remainder of 0. So that doesn't work. Okay, let's keep going. How about if I choose the next one, which is 16? 16 divided by 6 does indeed leave a remainder of 4, but 16 divided by 5 would give a remainder of 1. So that's no good. How about the next one, 22? 22 divided by 6 does give a remainder of 4 over here, but 22 divided by 5 gives a remainder of 2. Okay, let's keep going. How about 28? 28 divided by 6 gives a remainder of 4, and 28 divided by 5 gives a remainder of 3. So we've got our number is 28. And now we have to figure out when that number is divided by 7, what is the remainder? Well, 28 divided by 7 is 4. It's an integer, and the remainder is 0. So number 23, the answer is A. In the multiplication problem below, A, B, C, and D are different digits. What is A plus B? All right, A, B, A, and then it's a multiplication problem. So times CD is CD, CD. So each of these are different digits. Okay, well, the first thing I notice is that when you do this kind of multiplication problem, the very first step is, of course, going to be D times A, correct? And D times A is apparently just D. So D times A is just D. So that basically means that A is equal to 1. Correct? So this boils down to just 1B1 times CD is equal to CD, CD, like that. So something times CD equals CD, CD. So something, we don't know what, so I would just put it in brackets and call it X. Something times CD is equal to CD, CD. Okay, that's kind of interesting. I just used inspection or substitution. Let's just put in a couple numbers here. Let any number, let's say C equals anything you want, 7, D equals 2, and that means this would be 72, 72. So X times 72 is equal to 72, 72. And if you figure this out, this will give you X is equal to 101. All right? Now say, well, I'm not convinced if this is always going to be 101. Okay, no problem. Let's try a couple more values for CD. Let's say C is anything you want, 3, and D is equal to 4. Okay, so that means 34 times X is going to be 34, 34. And again, do the same thing. And again, you'll get X equal to 101. So this number is 101. And that basically means that B is 0. And A, we established earlier, was 1. So they want you to find A plus B. Well, A plus B is equal to 1 plus 0, which is 1. And therefore, number 24, the answer is A. Barry wrote 6 different numbers, one on each side of 3 cards, and laid the cards on a table as shown. The sums of the 2 numbers on each of the 3 cards are equal. The 3 numbers on the hidden sides are prime numbers. What is the average of the hidden prime numbers? Well, we've got A, B, and C. I'll let those represent our prime numbers. And on the other side, they've given us the numbers are 44, 59, and 38. Correct? Now, they give us an important clue that the sums of the 2 numbers are equal. So that means that A plus 44 is equal to B plus 59 is equal to C plus 38. And we have to figure out the average of the hidden numbers, and those numbers are prime. They want us to figure out A plus B plus C divided by 3, the average of those 3 numbers. All right. Let's see here. Where do we want to go? Well, the first thing is, before I start doing trial and error, I want to get rid of as much as possible. So let's subtract 38 from all of this. That will just leave me with C here, B plus 21 here, and this will be A plus 6. Okay, it's a little bit better to work with, I think. That's perfectly allowable. All right, now A, B, and C are prime numbers. So let's list some prime numbers, starting with 2, which is the smallest one, 3, 5, 7, 11, 13, 17, 19, 23, 29, and I think that should be good enough because the average of these 3 is pretty small, so I don't think I need to go too high. All right, now we got to figure out through trial and error here what can A, B, and C be. A, B, and C are prime numbers. All right. Well, let's see here. If C is 29, B would have to be 8 in order for this to work. But 8 is not a prime number. Okay, that's no good. How about if I make C equal to 23, B would have to be 2. That is a prime number. And A would have to be 17. And that's a prime number. There you go. That works. So A plus B plus C would be 17 plus 2 plus 23, all over 3, if we're taking the average. And that looks like 42 over 3, which is 14. So there you go. Number 25, the answer is B.